Number 8, we're going to see if these are equivalent. So we'll start with the fraction 5/3, all raised to the negative third power. And as we start to now that we've more or less are now dealing with all the exponent properties, there's a little more flexibility with how you or what order you apply the properties. But I'm going to start with first applying the -3. Next, I'm going to cross the line, change the sign, which means that 3 to the -3 is going to go to the numerator and 5 to the -3 is going to go to the denominator. I'm also going to prove that that's allowed. Normally, again, I would skip this step, but I could think of each one of these as a separate fraction. Multiplying fractions say that if I do this forwards or backwards, these are going to be equal, which means that I can think of moving the 5 cubed down, cross line, change the sign, and the 3 cubed up, and then remerging the fraction. Now, that is a lot of work. I normally don't do that, but I want to prove to you that this was allowed, that I can move each part on its own. And so in the future, I'll probably just go from there to there. All right, and then 3 cubed is 27, and 5 cubed is 125. Now we're going to go to the other example and see, is the other one 27 over 125? So 5 to the -3 over 3. Cross the line, change the sign. The 3 stays where it is. And it's going to be a multiplication dot, just like up here, how I was multiplying numerators and denominators. This time I did not write them as two separate fractions like I had mentioned. And now I'm going to keep simplifying. 1 over 125 times 3, which is 1 over 375. So yet again, these are not equal. These are not equivalent. This is, I believe, the third example that illustrates we have to be careful in how we read or interpret a problem. On this one, we say these are not equivalent. On the previous one, we said these were not equivalent. And we also looked at an example that dealt with R. It was problem number 5, and we saw those were not equivalent.